Take 3. We're in this section, continuity and one-sided limits. We're working some calculus today at your favorite math website. Go to math.com and subscribe if you'd like. Okay, we've got a piecewise function, and I know this is not traditionally the way things are written, but I'll write it up on the board here. Something maybe you're more familiar with. We're looking for the limit as x approaches 8 from the left, so that's what this little negative sign means, of the function o sub x. So probably the first time you've ever seen a function named o. But we can do that. We can name it anything we want. So we better get over here and get busy. Time goes by quick. We have o of x is equal to this piecewise defined function that you probably are more familiar with. And let's see, x plus 1 is going to be where its domain is x is less than or equal to 8, and we're asked to find the limit as x approaches the interesting number 8 of the function o of x. Let's sketch out a graph over here. We are approaching 8 from the left hand side, so let's say this is 8. So we're coming in from this direction, so we're only interested in the graph that's on this side of 8, and that's going to be this guy right here, because it says that its domain is less than or equal to 8. Let me just sketch out what this graph looks like. So if I were to plug 8 into this, I get 9. So we'll say that we'll say this right here, and of course it's a solid dot because we're including 8. Okay, and has a slope, and I don't know, 1. So it looks like it's doing something like that. And then we'll go ahead and sketch out what this graph is. Let me label this. This is at 9 here. And so this one's going to be an open circle. And it's at 8. If I plug 8 in, of course we're not supposed to, but I'm doing it anyway, right? We get 8 out. And it has a slope of 1, so we got 2 parallel lines. Okay? So we're coming in from the left-hand side of this guy, and of course you can see that if we're coming in from the left, we could just go ahead and plug 8 into the function and get 9 out, and so we can kind of see what it is, even though that's not what you're supposed to be doing. But you can take values on these one-sided limits, something really close to 8, like 7.999, right? Something really close to 8 coming in from the left, plug it in, and you can kind of see numerically what this guy is converging towards, and as you can see, it's going to be 9. And of course, let's just go ahead and look at, well, we got it, look at 8 from the right hand side. So we're going to be looking at this side of the graph coming in, and as you can see, we plug values in and we get closer and closer to 8. Right? Question is, where's this function discontinuous? And of course that's going to be at 8. We have to check 3 things, and first off, if we checked f of 8, we get 9 out, right? That would be this part. But the problem of it is this limit right here, as x approaches 8 of the function, this limit d&e does not exist. I'll just say d&e. The limit does not exist. So this limit must exist, and also this number must be equal to this number here in order for it to be continuous at 8. And this guy right here is what fails. So we got a couple things in here. We got the left-handed sided limit, right-hand sided limit, and continuity. Well, I'm not sure what happened there. Anyway.